Thank you for taking the time to watch my presentation on creating an effective learning experience in Canvas, integrating Desmos for teaching function transformations in college algebra. I'll do my best to explain how I created the lesson and why, and how I leverage this tool to enhance student learning and engagement. I did incorporate many of the suggestions of my peers while designing this final project. So this has changed from what I initially had planned. I had investigated two tools, the Math Whiteboard and Desmos. I didn't choose the Math Whiteboard due to issues with accessibilities. It hadn't been vetted, so there's no use to incorporate that into my course at this time. I chose to integrate Desmos into Canvas because it offers real-time graphing capabilities that make abstract concepts more tangible. Canvas provides a structured platform for collaboration and feedback. Combining these tools enhances students' understanding and engagement by providing a hands-on and interactive learning experience. Desmos was also effective at addressing the four C's. So, for communication, a student uses Desmos to create a graph of any function and uses annotations to explain how changing coefficients affects the graph's shape and position. I'll show you this in a moment as I go through the actual lesson and what students are expected to do. So in collaboration, students can work individually or in groups on a Desmos activity to investigate and compare the effects of different types of transformations on various functions. For critical thinking, a student explores the properties of various functions and uses Desmos to analyze and predict behavior for different base values, testing their hypothesis and real-time feedback, which is important. And for creativity, we'd be giving students a real-world scenario, and they'll be tasked with designing a complex graph using Desmos. So by integrating Desmos into lessons, we can foster an environment where students effectively communicate their understanding and collaborate with peers, engage in critical thinking, and unleash their creativity, all while working with an intuitive and interactive tool. So, how I started by defining clear objectives. So, I wanted students to know what my expectations were and what they could expect to see in this lesson. For function transformation, this means understanding translations, reflections, stretches, compressions, and everything having to do with transformations in college algebra. Next, I created interactive content that uses Desmos to visualize these transformations. Finally, I structured activities to balance individual work with collaborative work and discussions. So whenever you're using Desmos, you can either embed the content within Canvas or use links. I decided to use links. So again, looking at the course, I started by defining what would be covered in this particular lesson. I had an introductory lesson where I illustrated Desmos as well. So I taught them the concepts of transformation. I used Desmos to illustrate so that they could see it. And then I provided a tutorial on using Desmos. Now, for their activity, this would be a non-graded activity. Students were asked to enter a specific function. So in this case, I'll go ahead and enter x squared. So Desmos immediately graphs the function. And with transformations, I asked them to make transformations by changing the original function in specific ways. So for instance, I wanted them to see what would happen if you subtracted 2 from the variable and it shows the transformation that the graph shifted 2 units to the right. So I want them to play around with various transformations. So I also had them take the original function and add a value. Now you notice it shows all three, but if I just wanted them to focus in on the original one and the last one I did, they could toggle off that graph. And so they'll notice that when you add 3, the graph is lifted 3 units. So again, they were given various tasks to perform individually so that they could get acclimated to Desmos and start to understand the concept of transformations. I then had a group activity in which students were asked to work in groups that again dealt with the transformation and specific questions for them to research and discuss amongst the group members. Prior to assessing students, I wanted to ensure that students had a thorough understanding of transformations, so I created a discussion forum. After addressing the muddiest points and clearing up any confusion, I then assessed their knowledge by giving them a quiz. The last thing I did, which is very important, was to elicit feedback from students so I could make changes and improvements to the lesson and also provide them feedback that would help them with later concepts.